Hi mathematicians, this is Mr. Ahmed. I hope you're doing well. Today we are going to talk about factoring sums using the greatest common factor and the distributive property. So to first start out, we're going to say what a factor is. To factor, the verb. Factor means to write numbers as a product. Okay. So initially, you're going to see the number written as a sum, the result of adding numbers, and your job is to rewrite this as a product. So your job is to write it as some number times another number, and this number is going to be one number here. All right, the task here is to factor the sum using the GCF, the greatest common factor, and the distributive property. Okay? So, first of all, we're going to look at the steps for how we factor sums, and they're right over here. So just to give you the overview, the procedure is that we find the greatest common factor of each of the terms, so each of the numbers. Okay? Then we're going to write the greatest common factor as one of the factors. So that'll be listed right here. Then the other factor will be the sum of the quotients of each term divided by the GCF. I'll get to this in a moment, okay? All right, so first step is to find the GCF of each of the terms. So I'm going to do that. Using my prime factorization, I'm going to prime factor out 35 first. I know that 5 is a factor because it ends in 0 or 5. 5 times 7 is 35. All right. Then we have 63. I know that using the sum of the digits, 9 is divisible, or 9 can divide 63. So 9 is a factor. Let me just do this work down here. I'm sorry. All right, and then I know that 9 is a factor. 9 times what is 63? 7. Is 9 prime? No, so I'm going to prime factor that out into 3. Times 3 is 3 prime? Yes. Is 3 prime? Yes. Is 7 prime? Yes. All right, so we have 3 times 3 times 7, or 3 to the second power times 7. Okay? Basically, we're looking for the factors that they have in common. So you can do a review of what we've talked about. Remember, to find the greatest common factor, you take the lowest power of each different base. But even more visually, you can see that right down here. You're looking for the common factors. So I'm going to do this in green so you can see the connection, or gray. I see a 5 here. I don't see a 5 in 63's prime factorization. I see a 7 here. I do see another 7 in 63's prime factorization. So I'm just going to connect that to show you that that's the common factor. And that's it. That's the only factor they have in common. If they had more factors in common, then I would multiply those factors, and that would be the greatest common factor. But they only have one common factor, that's 7. Therefore, 7 must be the greatest common factor. Okay? So I'm going to write 7 right here as the greatest common factor. And then I'm going to look at what number is multiplying 7 to equal 35. Well, the answer is 5. So therefore, 35 divided by 7 is 5. So this will be 5. And then what number is, what's 63 divided by 7? Well, that's 3 times 3, which makes 9. So that number is going to be right here. And then if you were to do a quick check, you would see that 7 times 5 is 35, which is right there. And then 7 times 9 is equal to 63. So that works out there, okay? essentially what I've done over here is taken 35 and divided it by 7. And what I've done here is taken 63 and divided it by 7, because that's the greatest common factor. Sorry, 63. And that's how I'm getting these numbers that are listed right above here. And once you do your check, you'll notice that it all checks out. That's 35, 7 times 5 is 35, plus 7 times 9 is 63. So it all checks out. Now, what you have to do as a final check before you are done is, after you've multiplied to make sure that it all equals these numbers here, you then want to make sure that the numbers that are inside of this box, right inside of this group, are actually relatively prime. That means that the only number that can divide these numbers is 1. If that's the case, then you know you definitely do have your greatest common factor. If that's not the case and there's another number that can divide these, that means you did not pick the greatest common factor, and you have to go back to your prime factorization to see what other factor you might have missed that they have in common. Remember, if when you're finding the greatest common factor, you're just trying to match up the factors that they have in common. And if they have more than one factor in common, then you're going to multiply those numbers, and that will be your greatest common factor. Or if you think about what we talked about last week, to find the greatest common factor, you take the lowest power of each different base. Okay? All right, so that's how we do that. Another way to think about this is to use the area model. So in this case, I know what the area of each rectangle is. The area of one rectangle is 35. The area of the other is 63. So I'm going to write 35 and 63. And I'm trying to find the greatest common factor, the biggest number that they both share on this vertical length right here. And that is 7. So after doing this work, I know that it's 7. So I'm going to put 7 right here. And then I ask myself, 35 divided by 7 is equal to what? That's 5. And then I ask myself, 63 divided by 7, well, that's equal to 9. So I'm going to put the 9 right here. And you can see that the vertical length is one of our factors here, and the horizontal length is the concatenation of a length of 5 and 9. So I hope this video helps. You can take a look at the color coding to see how everything matches up. And now it's time to get to your guided practice and then complete your independent practice. So I hope this video was helpful, and have a great day.